Hi students, today I am going to show a few magic tricks. Yes, it's a magic show. Okay, shall we start? Ready. I am taking a transparent glass tumbler, okay, and gently I pour clean water in that. So what I'm going to do is I'm going to make an object bigger in size. Instantly I'm going to make the object bigger in size. For that I would like to take a lemon. What is that, Nana? It's a lemon. I'm going to make it bigger now. Okay, see carefully. I'm going to dip that lemon in the water. Observe carefully what happens to its size. Is the size increased or not? Yes. Okay, so when the lemon is in the water, its size is increased. See, very big lemon. Yes, Nana? So this is a simple trick we can do by using physics, right? So when the lemon is in the air, it appears its original size. So whenever you place that lemon in the water, it appears to be increased its size. Clear? Okay, you may ask why only lemon? Okay, so for that purpose I am taking another object, right, Nana? So like a ball I have taken. So whenever I place this ball in water, what is going to happen? Yes, its size also increasing. See, surprise. Yes, so that means whenever you place an object in water, its size is increasing. Is its size increasing actually? Actually the size of the object is, or the object size is changing? No. Okay, it is appearing its size is changing. Clear, Nana? So that is called apparent size of the object. We can say that apparent size. So let us do another magic. I am taking a pencil. See the sharp edge of the pencil. It is towards right. Okay, now you observe the sharp side of the pencil. Which side? Is it right or left? Now you can observe it is towards left. Right? I made that left as right and right as left. Clear, sir? So now the sharp side of the pencil appears towards left. See that as it is right side sharp pencil, it appears in the left. So one more activity for you. I am taking a paper on which I have drawn two colors. Okay, one is yellow, another one is blue. Now tell me which side is yellow, right or left? Right. Okay, and now look at that. Right side is yellow. See that. Now what is the right side color? It's blue. That means yellow changed to blue, blue changed to yellow. Is it correct? No. Okay. So here the yellow bar appears to the left and the blue bar appears towards right. Clear, sir? It's a simple trick. There is no trick actually, it's a science. Okay, it is science. A science principle is involved behind these all tricks. One more for you. Just I take a clean bowl. Okay, it's a clean bowl. What I'm going to do is I make the coin invisible and visible. Okay, see the magic. So it's a bowl, it is empty. Now I'm going to place a coin in this. So you can take any coin. I am taking a 5 rupee coin. Just place in the middle of the bowl exactly. Okay. Now you move back. Okay. Now you move back slowly until you cannot see the coin. Move back slowly. Yes, stop there. Okay. Now see the magic. Slowly he is pouring water in the bowl. So slowly what is going to observe? what are you going to observe? Right, slowly the coin is going to visible to you. Is it or not? Yes, see that. So, invisible coin becomes visible to you. So, this is also a science. This is also a science principle involved in this also. Clear, sir? Right. Let us see one more thing based on this principle. For this, again, I am taking a pencil which is straight. Now you check the pencil. Is it straight or is there any bendings or any cuttings are there? Okay? Clear. It's straight. Now see, I am going to bend the pencil by placing it in water. See it? Yes. What do you see there? A bent pencil or a straight pencil? You see a bent pencil there. Yes, Nana? Right. Whenever a pencil is placed in the water, it appears to be bending. Actually, the pencil is not going to bend. Okay? But it appears to be bent when it is placed in the water. Clear? So, if you have any doubt, let's check the pencil whether it is actually bent or whether it is straight. Okay? See that pencil? Yes, it's straight. Yes or no? So, but whenever it is placed in water, it appears to be bending. It is appearing as bent. So, the reason behind this also science. So, what science principle is involved in this? That I am going to explain today. So, the science principle involved behind this is refraction of light. What is that, Nana? Refraction of light. That refraction of light principle we are going to learn today. Clear? Very good. Yes, what is this refraction of light? So, refraction of light is nothing but change in the direction of light when it moves from one medium to another medium obliquely. Okay, so that means when light moves from one substance to another substance, it is bending. Clear, Nana? So, this phenomenon exhibited by light we are calling as refraction of light. Clear? Here you may get a doubt. Sir, what is medium? What is a medium? Okay, let us see. Medium is nothing but a substance through which light can propagate. Okay, so it is a substance through which light can pass. Those all substances we will be calling as medium. Right, Nana? So let us see some examples of medium. Air, water, glass, fog, smoke, vacuum, oil, paper, oil, etc. This all comes under medium because light can propagate through all these substances. Clear now? Very good. When light moves from one medium to another medium, it bends because its speed changes. So when light travels from one substance to another substance obliquely, then only it bends. Otherwise, in all the cases, the speed of the light will be changing. So let us observe the speed of light in different substances. In air or vacuum, the speed of light is 3 into 10 power 8 meters per second. So you can imagine the speed of the light. It is very huge, 3 lakh kilometer per second. Okay, it is denoted by letter C. And coming to water, the speed of light is 2.25 into 10 power 8 meters per second. Now you observe carefully, the speed of light decreased when it is in water. Okay, next, the speed of light in glass is 2 into 10 power 8 meters per second. The speed of light is more or less compared to water in glass. Okay, Nana? We know that the water has more denser than air or vacuum. Yes or no? Right. Similarly, glass is more denser than water. From this we can understand if the density of the substance increases, the speed of light is going to decrease. Okay. Now let us take air and water. Okay. Air is optically rarer medium and water is optically denser medium. Okay, sir. Regarding light, we are saying it is optically rarer, optically denser. In water and glass interface, which is rarer medium, which is denser medium? Exactly. So water is rarer medium and glass is denser medium, optically rarer and optically denser. Now let us see what happens when light travels from optically rarer medium to optically denser medium. For this I am taking air and water. So when light travels from air to water, the actual path of the light ray is the dotted lines. As the light is moving from optically rarer medium to optically denser medium, it is bending. Okay, as the speed is decreasing, it is bending towards the normal. See, the light ray is bending towards the normal. Right, Nana? Now, if the light moves from water to air, what happens? As here, the light is moving from optically denser medium to optically rarer medium, so that the speed increases, so it is bending away from the normal. The light ray is bending away from the normal. Okay. So, what if light incident normally on the surface? Okay, means perpendicular to the surface. That means it is called as normal incidence also. So when light incidents normally, the light speed changes, but there is no refraction. There is no refraction. Okay, that means when light incidents on the surface obliquely, then only it bends. Let us see why the pencil appears to bend when it is placed in water. Whenever a pencil is placed in water, it appears to bend due to the refraction of light. So, you observe carefully the tip of the pencil placed in the water. The light rays which are coming from the tip of the pencil which is placed in water refracts when it travels from water to air. Okay, so that those light rays we are calling as refracted rays. So whenever you see back along with the refracted light rays, they meet at a point A which is slightly above the point B, actual point of the tip of the pencil, so that the pencil appears to bend whenever you see from air to water. Now let us discuss some terms related to refraction of light. When light moves from rarer medium to denser medium. Here point O is called as a point of incidence, and MN, a dotted line, is known as normal. Normal we should draw at the point of incidence. That means it is drawn at the point of incidence perpendicular to the interface which is separating the two media. Right? And AO is a ray, it is known as incident ray. What is that? Incident ray. And OB is another light ray, that is called a refracted ray. Clear, sir? Next, MN is the normal. It is not a ray. Okay, students will confuse here. It is not a light ray. Just it is a line drawn. Clear? Next, coming to the angle made by the incident ray AO with normal is known as angle of incidence, and the angle made by the refracted ray OB with normal is known as angle of refraction. So angle AON is known as angle I, and angle MOB is known as angle R. Okay, when light moves from rarer medium to denser medium, it bends towards normal. Therefore, angle of incidence is greater than angle of refraction. Clear? Now let us identify when light moves from a denser medium to rarer medium. You pause the video and try to identify which is incident ray, refracted ray, and which is angle of incidence and which is angle of refraction. Did you? Okay, now let us see. Here BO is incident ray, OA is refracted ray, because the light is moving from denser medium to rarer medium. Okay, and as usual, Mn is the normal drawn to the surface perpendicular at the point of incidence O, and angle MOB is known as angle of incidence here, and angle NOA is the angle of refraction. So here, when light moves from denser medium to rarer medium, it bends away from the normal. So here, the angle of incidence is less than angle of refraction. Remember one point, Nana? Angle of incidence and angle of refraction are measured always from the normal. Okay, so these are the angles made by the incident ray and refracted ray with normal, not with the surface. Be clear. Now let us discuss why light bends when it moves from one substance to another substance, and why the speed of light changes. These things we are going to discuss now. So with the help of a demonstration, I would like to make clear this concept to you. So I have taken first two media as same, air and air. So whenever light enters from air to air, there is no bending. You can observe it very clearly. Okay, so the angle of incidence is 30 degrees and angle of refraction also 30 degrees. So there is no refraction. So to explain this bending of light, we need to consider the light as a wave. So that's why I have taken here wave form of light. So as when light moves from air to water, what happens? You can understand very clearly. See that the light bends. So the angle of incidence is 30 degrees and the angle of refraction is 21.8 degrees. So clearly we can see that the light is bending when it is moving from air to water. There you can see a partial reflected ray. That light ray is called, or that wave is called as partial reflection. So now let us discuss, or let us see whether the speed of light is changing or not. The speed of light in the air is 1c, that is it is nothing but 3 into 10 power 8 meters per second, 1 into c. Coming to water, you observe carefully, it is 0.74 c. So it is clear the speed of the light is decreased when it moves from air to water. Similarly, let us try to understand whether the light intensity is changing or not. Intensity is nothing but the amount of light entering into the medium is changing or not. So let us take, in air it is 100% the intensity of light. Now let us see what is the intensity of light in water. You observe carefully, the intensity of light in water is 96.73%. So total light is not entering into the water. Some part of the light is reflecting back. That is we learnt as partial reflection. It is 3.27% is reflecting by the surface of water and air interface. Clear? Now the thing is, we need to understand why the light is bending there. You look at the interface clearly. So the magic is happening at the interface. So you observe carefully a light wave. When the light wave, one end of the light wave is very near to the surface, but the other end is far away from the surface. When the near end of the light wave enters into the water, its speed reduces. Okay, during that time, the far end of the light is going to travel a more distance. So with the same speed it is traveling more distance. So as there is a change in the speed of the both ends of the wave, the light is bending here. Clear, sir? So this is the reason why the light is bending. So with the help of ray theory we cannot explain this. That's why I consider this as a wave of light. Now look at carefully, when light incident normally, what happens? When light incident normally, what is the angle of incidence? Very good. The angle of incidence is 0 and angle of refraction also 0. We can say that there is no refraction. There is no refraction. Now look at the speed of light in the air and water. The speed of light, can you guess what could be the speed of light in air and water? Will it be same now? Let us see that. So the speed of light in air is 1c. Okay. What about in water? In water it is 0.7 c. See, here the speed is decreased. Clear, sir? But there is no refraction. But the speed of the light is changing when it enters from one medium to another medium. What about intensity? Will it be 100% in water? Let us check that also. In air, it is 100%, but in water, it is 97.84%. Okay, that means some part of the light is reflecting back along with the incident ray. So that is normal reflection. Already you learned in reflection of light. Clear? So students think that total light will be entering into the water. No. Partial light will be reflecting back. Clear, sir? Now coming to ray theory of light. So here the angle of incidence is 30 and the angle of refraction is 21.8. Now observe the speed. Okay, now I am changing the color of the light. Let us see the speed of light. Whether is there any change in the speed of the light? Again 0.74 c. Okay, what is the angle of refraction? 21.8. Now let us change the color of light. Now I have taken another color. What is the angle of refraction? 21.8. And what is the angle of speed of light? 0.74 c. Now look at this blue color. The angle of refraction has changed 21.7, but the speed is same. Clear, sir? So the refracted light color is not changing and the speed is not changing, but the angle of refraction will be changing. That's why I said the refractive index depends on the color of the substance, or that is wavelength of the substance. Now look at when light moves from denser medium to rarer medium, what happens? When it moves from water to air, look at carefully what happens to the angle of refraction. Is the angle of refraction greater than angle of incidence? Yes. See that the angle of refraction is greater than angle of incidence. What does it mean? It means the light is bending away from the normal. Now the light ray is bending away from the normal. So why the light is bending away from the normal? So to explain this again, we need to consider light as a wave. Then we can understand why the light is bending away from the normal. Okay? Right. Let us measure the speed here. It is 0.7 c and it is c. Clear? The speed of the light is increased when it moves from denser medium to rarer medium. Optically denser to optically rarer. As a wave. So when light moves from water to air, its speed increased so that it bends away from the normal. Now you look carefully to the surface. What happens to the surface? What happens at the surface? At the surface, the light, the wave at the surface, one end of the wave is reaching earlier than the other end. So that when the first end reaches the surface of the water and air, its speed increases, but the other end is moving with the same speed. So there is a change in the speeds to the one end and the other end, so that the light is bending here. Clear? So this is the reason why the light bends when it moves from one medium to another medium. Let us discuss about refractive index of the medium. We know that when light moves from one medium to another medium, its speed changes. So which property of the substance is going to change the speed of the light when it moves from one medium to another medium is nothing but refractive index of the medium. So when light interacts with the atoms and molecules of the substance, its effective speed reduces, so that the speed of the light is going to change. The ratio of the speed of light in vacuum to that in the substance is the refractive index of the particular substance. And it is denoted by letter small n or mu. It is a Greek letter mu. So different textbooks will be using different notations. So I'll be using n as the refractive index. Mathematically, it can be written as n is equal to speed of light in vacuum divided by speed of light in the medium. So it can be written as n is equal to c by v, as c is the speed of light in vacuum. We know that its value 3 into 10 power 8 meters per second. Okay, from this we can write a derivation. N is inversely proportional to v. Here n is inversely proportional to v. What does it mean, sir? So it means that the refractive index and the speed of the light in the particular medium are inverse. Okay, that means if the refractive index increases, speed of the light will be decreasing. If the refractive index decreases, then the speed of the light will be more in that particular medium. So refractive index has no units, as it is the ratio of same physical quantities. And the refractive index of vacuum or air is equal to 1. The refractive index of all other substances will be greater than 1, because the air or the vacuum is the less denser substance. So all other substances will be more denser than air. So the refractive index of all other substances will be greater than 1. Now let us see here. A light moves from one medium to another medium. So I have taken two media here. The refractive index of first medium is n1 and the refractive index of second medium is n2. The speed of the light in the first medium is taken as v1 and in the second medium is v2. Here I have taken n1 is greater than n2. What does it mean, sir? It means that refractive index of first medium is greater than refractive index of second medium. That means the first medium is optically denser medium and the second medium is optically rarer medium. We know that when light passes from optically denser medium to optically rarer medium, it bends away from the normal. Okay, here you can understand the refractive index is more, then the medium is denser, and the refractive index is less and the medium is rarer. Here you can write the relation between n refractive index and speed as n1 by n2 is equal to v2 by v1. Remember this equation? Observe carefully. n1 by n2 is equal to v2 by v1, as refractive index is inversely proportional to velocity. By using this equation, you can calculate the speed of the body in a particular medium. Okay. Now let us see on what factors the refractive index depends. The refractive index depends on nature of the medium, wavelength of the light used, and the temperature. On these three factors, the refractive index of material or the substance is going to depend. Some refractive index of medium I have given in the table. So here medium, material medium, and its refractive index I have given. So from this table we can grasp so much data. So what is that? So refractive index is more than the speed is less. Already we discussed. Yes or no? Yes. Now you tell me, in which material medium the speed of light is least? Once again, in which material medium the speed of light is least? Exactly, it is diamond. Right, one more question for you. What is the speed of light in benzene? What is the speed of light in benzene? So to calculate that, we have a formula n is equal to c by v. Here n is given as 1.5. V we need to calculate. Therefore v is equal to c by n. That is v is equal to 3 into 10 power 8 meter per second by n is the value of refractive index of benzene, that is 1.5. So you will be getting 2 into 10 power 8 meters per second. This is the speed of light in the benzene. In this way you can calculate speed of light in any particular medium. Now let us compare kerosene and rock salt. In these two substances, where the light can propagate faster. In these two substances, where light can propagate faster. Is it kerosene or rock salt? Yes, your answer is correct. It is kerosene, because its refractive index is less compared to rock salt. As the refractive index is less, speed will be more. Yes. Now let us discuss about relative refractive index. What is meant by relative refractive index? It's very simple. Refractive index of one medium is compared with refractive index of another medium, then it is known as a relative refractive index. You always remember relative is nothing but comparison. Okay? Here relative refractive index is nothing but refractive index of one medium with respect to another medium. So let us take a refractive index of water as NW and refractive index of glass is NG. Then refractive index of glass with respect to water can be written as NG by NW. Okay, listen carefully. It is refractive index of glass with respect to water. Means here we are comparing refractive index of glass with respect to water. So that it can be written as Ng by Nw or it can be written as Ngw. Clear? Let us see an example. Refractive index of water is given as 4 by 3 and refractive index of glass is given as 5 by 3. And is asking what is the refractive index of water with respect to glass. So here you can write NWG is asking, so that NW by NG is equal to, you will be getting the answer as 4 by 5. Clear, sir? Very good. What could be the refractive index of glass with respect to water in the above example? Refractive index of glass with respect to water. Yes, it is 5 by 4. Simply reciprocal. Now let us see one more question. Refractive index of diamond is given as 2.42. What is the meaning of this statement in relation to the speed of light? So this means that the speed of light in diamond will reduce by a factor of 2.42 as compared to its speed in air, because its refractive index is 2.42, so that it is 3 into 10 power 8 by 2.42. So the speed of light is reduced by a factor of 2.42 when compared with the speed of light in air or vacuum. Clear? Now let us learn laws of refraction of light. The refraction of light on going from one medium to another takes place according to two laws of refraction, which are known as simply laws of refraction of light. These are, first one, according to first law of refraction, the incident ray, refracted ray and normal to the surface lie in the same plane. These three lie in the same plane. AO is incident ray here, and OB is the refracted ray, and OM is the normal. These three lie in the same surface. Same plane is nothing but what, Nana? Same surface. Next, coming to second law of refraction. The second law is also known as Snell's law. So the second law gives a relationship between the angle of incidence and the angle of refraction. This relationship was discovered by Snells experimentally, so that it is known as Snell's law of refraction. According to Snell's law of refraction, the ratio of sine of angle of incidence and sine of angle of refraction is a constant for a given pair of media. Therefore, it can be written as sine I by sine R is equal to constant. This constant is known as relative refractive index of medium 2 with respect to medium 1. That means if the refractive index of the denser medium is N1 and the refractive index of rarer medium is N2, then sine I by sine R can be written as N2 by N1. Here medium 1 is the denser and medium 2 is the rarer, because light is moving from denser medium to rarer medium, so that denser medium is the first medium and rarer medium is the second medium, and it can be written as N1 sine I is equal to N2 sine R. Let us verify Snell's law by conducting a simple experiment. For this experiment, I have taken air as a rarer medium and glass as a denser medium. So now light is moving from rarer medium to a denser medium. So let us see for an angle of incident 30 degrees, what could be the angle of refraction. So I am adjusting it. For an angle of incidence 30 degrees, the angle of refraction is equal to, how much we got? It is 19.5 degrees. Okay, now the light is moving from rarer medium to denser medium, so that it is bending towards normal. So now verify for another angle of incident. So for that purpose I am taking another angle of incidence as 45 degrees. Let us see what could be the angle of refraction when angle of incidence is 45. So it is how much, Nana? 28.1 degree. So we make these all angle of incidence and angle of refraction in a table so that we can calculate what could be its ratio. Now let us check for one more value, that is 60 degrees. How much? That is 60 degrees. So angle of incidence is 60 degrees. Then what is angle of refraction in this case? Let us observe carefully. It is 35.3 degrees is the angle of refraction. See, as the angle of incidence increases, the angle of refraction also increasing. Okay, so by using this data, let us verify whether sin I by sin R value is constant or not for a particular medium. According to Snell's law, sin I by sin R is equal to constant. That is a relative refractive index of second medium, or it can be written as refractive index of second medium with respect to first medium. Here first medium is nothing but from which light is moving. Second medium is nothing but to which light is moving. Okay, now let us verify by taking the first set of values, I1 equal to 30 and R1 is equal to 19.5. If I calculate, I will be getting its value as 1.51. Coming to second set of values, the result is 1.49, and from the third set of values, its calculation is 1.5 is giving the result. Now observe carefully, in the first we are getting 1.51 and second we got 1.49 and third it is 1.5. Whenever you do experiments, you should repeat the experiment with different values so that you will be getting the result accurately. So after getting all the values, you calculate average of these all values, that will be the exact value of the experiment. So for that purpose we are averaging all the values which I got, 1.51 plus 1.49 plus 1.5 by 3. Here we have done the experiment for 3 times, so that is equal to, the result is 1.5. Now let us check what is the value of refractive index of the second medium divided by refractive index of the first medium. So here refractive index of the second medium is n glass by n air, that is equal to n glass is 1.5 and n air is 1, the result also giving 1.5. So that Snell's law is verified. Now let us calculate a numerical. It is given that a ray of light is incident on a glass slab at an angle of incidence 60 degrees. If the angle of refraction be 37.5, calculate the refractive index of glass. So here it is given that light is moving from air to glass. Okay, so at the air glass interface, the angle of incidence is 60 degrees and the angle of refraction is 32.7. So we need to calculate n2 value. n1 is the air and n2 is the glass. So from Snell's law, n1 sin I is equal to n2 sin R. Therefore n2 is equal to, I can write n1 sin I by sin R. So if you simplify that, you will be getting the value is 0.59, that is approximately 0.6. So the refractive index of glass slab is how much, Nana? 0.6. In this way we can solve the problems based on Snell's law.